Hello class, good morning. Today we are going into objective 5, and on test 2 we will cover objective 5, 6, 7, and 8. And also after objective 6 we have a quiz, okay? So let's jump into objective 5. In objective 5, we're going to be solving linear equations of the form x plus a equals b and ax equals b. Okay, so for part 1, we're going to talk about how to determine whether a given number is a solution of an equation. So first, I want you guys to take note that this is an equation, okay? And we're trying to see if -2 is the solution. So how do we do that? We do what we previously did when we plugged in the number that they give us. We plug that in for x and we work it out. But because this is an equation, we have two sides of it. So we have the equal sign, and then we have the left side and the right side. So we want to see if the left and right side equal. If the left and right side equal, then it is a true equation. If they do not equal, it's a false equation, okay? So when we plug in -2 in for x, when we work it out on the left side, we get 2 times -2, which is -4. We bring that +5 down, and -4 plus 5 is 1. On this side, when we plug in the -2, when we square -2, we get 4. Then we bring that -3 down, and 4 minus 3 is 1. So because both sides of the equation equal, this is a true equation, and the answer to their question is yes, -2 is the solution of the equation, okay? So in this objective, we are going to be solving linear equations of this form and this form, okay? So here they gave us the solution and we plugged it in to see if that was the answer. And this is how we will check the problems that we're about to do. So when you solve the equation, the way to check that your answer is correct, all you have to do is plug it in and both sides of the equation should equal. So since a true equation means that both sides of the equation equal, that means that whatever we do to one side of the equation, we have to do to the other side of the equation. So if we add 3 to one side, we have to add 3 to the other side, because we have to always keep both sides of the equation equal. So let's do another example to determine if our solution is -4. So we're going to plug in -4 everywhere we see a x, okay? So we're going to just rewrite everything, and then we're going to plug in that -4. Oh, to actually plug in the -4. And when you guys work these problems, please, please, please remember that this is the left side and this is the right side. This equal sign divides the equation, okay? As we move on and we start doing different operations along this equal sign, I see too many people doing the same doing things on the same side. And that is not how this works. You have to do it to this side and this side. So as we continue, you guys are going to kind of understand what I'm talking about a little bit more. So on the left side, we have 4 plus negative 20, and that is negative 16. So here we got negative 4 squared, which is positive 16. Here we have a minus 2 times a negative 4, which is positive 8. So on this side, we have 24. So we know that negative 16 and 24 does not equal. So we take our equal sign and we put a slash through it. Remember, I showed you guys earlier that that symbol means it is not equal to. So to answer the question, is negative 4 a solution of the equation? The answer is no. So this equation here is a false equation. All right. So moving forward, the equations that we look at, we're going to assume that they are true equations so that we can do our different operations so that we can solve them. All right. So let's look here. So let's go into part 2. You guys can go ahead and start copying that down. For part 2, we're going to actually start solving the equations of the form x plus a equals b. And if you don't know what the term solve an equation means, basically we're just going to find the solution of it, okay? And one method that we use to find the solution of an equation is the addition property of equations, all right? So basically what this rule is saying is that whenever we have something added or subtracted on one side of the equation, in order to move that from that side of the equation, we have to do the opposite operation. So let's look at that in action. So for example, number 1, we have x minus 4 equals 2. So when solving an equation, the equation is solved when we have x equals something. So our end goal is basically to get x by itself. So an easy way to think about this is, what is stopping x from being by itself? If we want to get the x by itself, we have this minus 4 that's in the way. So because this is an equation and both sides have to equal, whatever we do to one side of the equation, we have to do to the other side of the equation. And in order to move things across the equal sign, we have to do the opposite of that operation. So if we have minus 4, a way to get rid of the minus 4 will be to add 4. So if we think about negative 4 plus 4, that's 0, right? So now the only thing we have over here is x. Do you guys see that? So now we have x on the left side, we have our equal sign, and on the right side we have 2 plus 4, which is 6. Okay? So it's very important for you guys to understand how this works, because eventually we're going to have a lot of different things on the left and the right side that we will eventually have to simplify and all of that. So I really want you guys to get a good grasp of this in the beginning. So now let's look at example 2. We have y plus 3/4 equals 1/2. So remember, we want to get y by itself, but we have this plus 3/4. So if we want to get rid of it, we need to do the opposite of we need to do the opposite of plus 3/4, and we need to subtract 3/4. All right. Now, who remembers how to subtract fractions? So to add and subtract fractions, we need that common denominator. So we have 2 and 4. So we can make our denominators 4. This is already 3/4. Now we have 1/2, and we need it to be something over 4. So if we multiply 2 times 2, we can get 4. But in order for the fraction to continue to be equal, whatever we multiply by the denominator, we have to also multiply by the numerator. So if we did 2 times 2 here, we have to do 1 times 2, which is 2. Okay, so now we can actually work this out. So y equals 2/4 minus 3/4. So now we basically have 2 minus 3/4, which is -1/4. So for example 2, y equals -1/4. So with the fractions, of course, it's a few more steps, but it's still doable. All right, let's look at example number 3. We have x plus 15 equals 23. We want to get the x by itself. So where we have plus 15, we need to subtract 15. All right, so plus 15 minus 15 is just 0. So we have x left on this side of our equal sign. And on this side of the equal sign, we have 23 minus 15, which is 8. So x equals 8. All right. So let's look at number 4. We have 26 equals y minus 14. So we want to find the variable. This is the variable that we want to get by itself. So for this problem, we have y, and we need to move the -14 over to the left side of the equation. So the way that we do that is we add 14. So -14 plus 14, of course, is 0. So we have y on the right side by itself. And on the left side, we have 26 plus 14, which is 40. So we have 40 equals y. And you can rewrite it to say y equals 40. Okay, so this is how we solve equations that are in the form x plus a equals b. Pretty simple. So now let's look at part 3. For part 3, we are working with the form AX equals B. So with the first form, it was going to be addition or subtraction, and with this form, it's going to be multiplication or division. So the property is the multiplication property of equations. All right. So in words, it's used to remove a coefficient by multiplying each side of the equation by the reciprocal of the coefficient. So basically what we're doing, whatever operation is going on, we're doing the opposite of it. The same way over here, if addition was happening, we subtracted, and if subtraction was happening, we added to move it to the other side. So we're basically doing the same thing. We're doing the opposite of the operation. So let's look at number 1. We have 3 over 4z equals -9. Okay? So 3 over 4z is being multiplied, right? But when we divide by fractions, remember we have to multiply by the reciprocal. That's where all of this comes in, okay? So what we're basically doing, and you can see this different ways, so I'm going to write it a few different ways so y'all can see it. So basically what we're doing, this is being multiplied by the z. So we're basically dividing both sides of the equation by 3 over 4. But because this is a fraction, the same way we divide by 3 over 4 is to multiply by 4 over 3. So I'm going to erase that. And I'm going to write it. So both sides, I'm going to multiply by 4 over 3. So this is my 4 over 3 that I am multiplying by both sides, okay? So remember when we talked about anything divided by itself was 1. So 4 divided by 4 is 1, and 3 divided by 3 is 1. So we have z over here by itself, which is exactly why we did this, because this is what we wanted. If you don't cross this out, of course you can multiply straight across and do 4 times 3 is 12, 3 times 4 is 12, and 12 over 12 is 1. Okay? So now over here we can multiply straight across, or we can cross out because we know that we're multiplying straight across. So this 9 is just over a 1. So we can multiply straight across and get 4 times 9, which is 36, and 3 times 1, which is 3, and we can do 36 divided by 3 to get 12, or we can look at the 3 and the 9 and say 3 goes into 3 one time and 3 goes into 9 3 times. So now we have 4 over 1 and 3 over 1, and of course 4 times 3 is 12. Okay, so you can get to the final answer a few ways, but as long as you show your work, show which way you used, you can use whichever method is easiest for you. So the answer to example 1 is 12. All right. So let's look at example 2. For example 2, we don't have a fraction. So we see that we have 6x equals 14. So we know that we want the x by itself. The 6 is stopping the x from being by itself. So we have to think, what is the 6 doing with the x? The operation is multiplication. So a way to get it to the other side is by doing division. So if we divide both sides by 6, 6 over 6 is 1. So we're left with x on this side, which is exactly what we wanted. And then we have 14 over 6 left on this side, which does not divide through evenly. So we can reduce the fraction. 14 and 6 are both divisible by 2. So we can reduce the fraction to get 7 over 3. All right. So now let's look at example 3. We have 3x over 4 equals -9. So here we have a fraction, so that means we're going to be multiplying by a fraction. What fraction are we multiplying by? All right, hopefully everybody said 4 over 3. And this problem is similar to example 1. It's just a different way that you may see it. So you may see your variable not connected to the fraction like this, or you may see it in the numerator of the fraction, or even in the denominator, okay? So now we're going to multiply each side by 4 over 3. And of course, 4 over 4 is 1, 3 over 3 is 1, 3 divided by 3 is 1, -9 divided by 3 is -3, okay? So on this side, we're left with x, and on this side, we're left with 4 times -3, which is -12. So let's look at number 4. On this one, we have that x in the numerator again. So the reciprocal that we're going to multiply by is 5. Well, -5 over 2. So we're going to multiply each side by -5 over 2. So -5 times -2 is +10. 2 times 5 is 10. So 10 over 10 is 1. So we have just x left on this side, which is what we wanted. If in your attempt to cancel something out and in your calculations you still have something, that means you need to go back and recalculate. On this side, we have -5 over 2 times 6. And of course, 6 is the same thing as 6 over 1. You can multiply straight across, or you can cancel some things out. So if we multiply straight across, we'll have -5 times 6, which is -30. 2 times 1, which is 2. So -30 divided by 2 is -15. Or if you decide to cancel some things out, we can look at the 2 and the 6. 2 can go on to 2 once. 2 can go on to 6 3 times. So we'll be left with -5 times 3, which is still -15. All right. So let's look at example 5. Now with example 5, this is one of the ones that you have to pay attention, okay? All of the ones that we have done previously were simplified enough to start moving things. For this one, it is not fully simplified. So you should notice on the left side, we have two like terms that need to combine. So we have 5x minus 9x, which is like 5 apples minus 9 apples, which would be negative 4 apples, which would be negative 4x, okay? Then we bring our equal sign down and we bring our 12 down. Now that the left and the right side are both simplified, we can start moving things, okay? So because we have a negative 4 being multiplied by the x, we can divide by negative 4. So negative 4 over negative 4 is 1. Then we have just x, just 1x, which remember when we have the 1x, we don't have to write the 1, we just write the x. On the right side, we have 12 divided by negative 4, which is negative 3. Okay? Oh, and another thing that you guys are not doing on your work, you're not circling your answers. So on your work, your answers should be in a box, circled, or you can actually take a highlighter and actually highlight it. You know, that'll make it easier for me when I'm on the computer looking at your work. All right, so let's look at example 6. Here we have 4x minus 8x equals 16. So please, please, please do not add ax and add ax. I see this so much, and this is not what you're supposed to do. You cannot do that stuff on the same side of the equation. First of all, you're only supposed to do that across this equal sign. So we need to first look at each side and see if it is fully simplified. So here we have 4x minus 8x, which we have a term with an x and a term with an x, meaning we can combine that. So 4x minus 8x is negative 4x. Then we have our equal sign and we bring our 16 down, okay? Now we see that we have this negative 4 being multiplied by the x again, so we can divide both sides by negative 4. Negative 4 over negative 4 is just 1. So we have x left on the left side, and on the right side we have 16 divided by negative 4, which is negative 4. All right. So make sure that each side is simplified before you start moving things across that equal sign. So what you guys just learned is the basics on how to move things across the equal sign using the opposite operation. If it's addition, you move it by subtracting. If it's subtraction or negative, you move it by adding. If it's being multiplied, you move it by dividing. And if it's being divided, then you move it by multiplying. All right. And with the whole dividing thing, when it's divided and you multiply it in a fraction, you'll be multiplying by the reciprocal, because that's how we divide fractions. We multiply by the reciprocal. All right, so let's get into some more examples. So number 1, we have x plus 5 equals 7. So we want x by itself. And this plus 5 is disturbing that. So we need to subtract 5 from both sides of the equation, the equal sign, all right? So 5 minus 5 is 0, so we have x over here. Then we have 7 minus 5, which is 2. So x equals 2. That is the answer. All right, for number 2, this 2 is positive, right? It's not a negative sign in front of it, so it's positive. So the way to get rid of a positive number is by subtracting it. So 2 minus 2, of course, is 0. So we have a left on the left side. 8 minus 2 is 6. So the answer to number 2 is a equals 6. For number 3, we have this plus 7, so we need to subtract 7. 7 minus 7 is 0, so we're left with the b on the left side, which is what we want. And 7 minus 7 is also 0. So the answer is b equals 0. For number 4, again, we have this 10 plus m equals 3. This 10 is positive, so we subtract 10 to get rid of it. So 10 minus 10 is 0. We're left with m. And on this side, we have 3 minus 10, which is negative 7. So the answer to number 4 is m equals negative 7. All right, let's look at number 5. We got 2 equals x plus 7. So that means that we need to subtract 7. So we have x left on the right side, and on the left side we have 2 minus 7, which is going to give us negative 5. And you can rewrite your answer to say x equals negative 5. For number 6, we have a fraction, which is you guys' favorite. So we have m plus 2 over 3 equals negative 1 over 3. So here we have the same denominator, so this one should be a breeze. So because this one is addition, we need to do subtraction. So m equals, and you can rewrite it so you can see it better. So I have negative 1 over 3 minus 2 over 3, and you know that when we have that same denominator, we're basically looking at negative 1 minus 2. So negative 1 minus 2 is negative 3, right? And negative 3 divided by 3 is negative 1. So let's look at number 7. We have 5x equals negative 15. And the 5 is being multiplied by the x, so that means we need to divide both sides by 5. So 5 over 5 is just 1, so the x is left over here by itself. Then we have negative 15 divided by 5, which is negative 3. So right off the bat, we see that we have multiplication going on with the x in both cases. So we know we're going to be dividing by that coefficient. So hopefully for number 8, you guys said that 6 divided by negative 3 is negative 2. And for number 9, hopefully you guys said that 0 divided by negative 5 is 0. And that's one of the properties that we talked about. All right, so let's look at number 10. We have negative 2 over 3 times d equals 8. So because multiplication is happening, that means we need to divide. But when we divide fractions, we have to multiply by the reciprocal. So that means that we need to multiply both sides of the equation by negative 3 over 2. So we have negative 3 over 2 times negative 2 over 3d equals negative 3 over 2 times 8. So of course, multiplying by the reciprocal is just going to give us 1. So we have d on this side, and over here we can do negative 3 times 8 divided by 2, or we can do some simplifying. We could take the 2 and the 8 and divide both of those by 2 to simplify. Either way, we're going to get negative 12 as our answer. All right, so for number 11, you should multiply both sides of the equation by negative 8 over 3, and you should get that z equals negative 24. For number 12, you want to pay attention to the left side of the equation. We see that we have some like terms over here. So this 2m plus 5m can be combined to be 7m equals 49. Then we have a problem like these over here where the 7 is being multiplied. So we divide it and we get m equals 7. For number 13, first you have to combine the like terms. So 7d minus 4d is 3d, and that equals 9. And when you divide both sides by 3, you get d equals 3. For number 14, we have a fraction on both sides. So we know that we're going to be multiplying by a reciprocal. So hopefully you guys said negative 4 over 3. So if you said negative 7 over 6, that is incorrect, and we want to multiply by the reciprocal. That's going to get us our variable by itself. If we multiply both sides by negative 7 over 6, it will be something that we did, but it wouldn't get us closer to the answer. So to get closer to the answer, remember we want to get our variable by itself. So we're going to multiply both sides by negative 4 over 3. So that's going to cancel, and we're going to be left with b on the right side. On this side, we can do negative 4 times negative 6. And in the denominator, we can do 3 times 7 and then simplify that. Or we can look at the 3 and the 6 and simplify it as if it was 6 over 3, which would be 2. So we know that we have negative 4 times negative 2, which is positive 8. And then we have 1 times 7, which is just 7. So our answer for number 14 is B equals 8/7. That wraps up objective 5. Make sure you check WebAssign for your practice problems and your actual homework for objective 5. Have an awesome day. Bye.